Hi, my name is Alex Bordei, and I run the product organization here at MetalSoft. And in this video, I want to elaborate a bit on the topic of AI in bare metal infrastructure, right? And there is a lot of debate around this space, and a lot of professionals are telling me, for now, I'm not gonna allow any kind of AI, to operate in my mission critical infrastructure. On the other hand, we do have several customers saying, "Well, I can't wait to be able to do automatic remediation, right? I want self-healing. I want to allow the AI to operate this thing, and I want to SSH onto the switches anymore. I just want it to to just operate automatically, right? So the question is, how do we get from where we are now to this point where we can do automatic remediation and or just automatic operation, right? Agentic autonomous operation of physical infrastructure, right? And just to set things clear, I believe that is the future. I believe the future is autonomous infrastructure operation, right? And it's totally doable, but there are a few stages, obviously, through which companies have to go through to get to that point. Some are closer to that goal than others. And MetalSoft can help you achieve that goal faster, or at least at the very least, set up a very solid foundation to get to that point. So in this video, I want to talk a bit about what's required, right, in order to have to be able to operate using AI and to do operation diagnosis and remediation using the AI. What are the building blocks? Whether or not you're using MetalSoft to do that, right? You still need those respective components. So let's get started. So the first thing that you want to do is you want to put the layer on front of your hardware. And that is because while you can allow the AI to actually affect changes on your switches, for example, obviously that's not such a good idea. I mean, it can do that. Technically, it's possible. But the problem is it's not deterministic. It's not clear what is it going to do today versus tomorrow, what is going to be the exact same result. And obviously you cannot, play around with this thing. It needs to work every single time. And also there's a security aspect that you need to think about. You don't want to take the config file and set it over to the LLM. Even if it's locally on-prem, it may be shared across the entire organization. It's not something that you want to, you want to take out of your particular domain. And also, each individual vendor implements things differently. The AI may be confused. If it talks with one switch now and another switch, it may get confused. And in a heterogeneous environment, it may create chaos. Um, and so we recommend placing this layer in front of your hardware. And you'll notice that I'm talking a lot about switches in this video, but everything that I'm saying is applicable to to everything. Deterministic tools. Right. Okay. So these tools are what the AI will be using to interact with the switches, right? And the servers and the storage and the virtualization layer, potentially firewalls and so forth, right? So the tools will say something like, anything ranging from configure this VLAN on this port to create a layer to broadcast domain between, from this server to this server, and then let the tools figure out the interconnects, right? So the level of abstraction that the deterministic set of tools will be presented to the AI may be different from implementation to implementation, but generally speaking, that's their role. And one of the very important elements that this deterministic set of tools will implement is access controls, right? And so you have a key here. This applies to two things: is evaluate whether the person using the AI, because I have a user here somewhere, that is talking to the AI. This guy here is talking to AI. Does this guy have actually access to effect changes, right? And it may not have. So there's a process that needs to happen here, and we will have to talk about that. But in general, the the deterministic set of tools should have these access controls, and they also should be deterministic, right? And they should enforce, just like an API enforces a set of credentials and API keys, and they should enforce the same level of credentials. So it works towards the user, and also it works towards the switches, right? Because the set of keys that or SSH credentials, for example, or API credentials for connected to the switches, they need to be stored somewhere. So they could be stored, in an HSM, or like HashiCorp Vault, or they could be stored somewhere in a database, right? In MetalSoft, they're stored either in HashiCorp Vault or in the MetalSoft database itself, and the deterministic tools are making sure that whoever AI or human is accessing the respective switch, it does so transparently and correctly, and with all the RBAC related access controls in place. So this is the first part. The second part, which is surprisingly difficult to achieve in most organizations, is the set of data, clean data about the infrastructure. And I'm going to put it here. And I'm going to call it topology information. Topology. So it's topology and equipment information or equipment inventory, basically cabling data. It's these wires here that describe how things are connected to each other. And this is a very important concept, and this is unfortunately missing in many organizations. Basically, the information is stored in Excel files, or if it's not in Excel files, it isn't accurate because the cabling was introduced later on, it wasn't updated, and so that is unfortunately a big issue with leveraging AI in organizations, and it's having this accurate information, and a few organizations have started connecting that. Now, obviously, with MetalSoft, the way this works is that it's automatic. Right? When you register a rack, the cabling gets automatically detected. So the topology information is accurately depicted and accurately maintained automatically. But you have to start with something like MetalSoft to build that accurate information. And once the topology information is there, what this does is that it helps troubleshooting, right? It helps the diagnosis component, which is the second part, as well as the operations part. But if operations can be done via the tooling and via the abstract parts, diagnosis requires topology information. If you don't know what talks to what, you won't be able to understand what's happening, right? So topology information is important. And then there's yet another piece that's very important that a lot of people tend to forget, which is intent information. So I'm going to put this guy here. Now, intent information means or desired end state, right? And desired end state is something like, well, this guy has to be able to talk to this other guy here. They're part of the same application. They need to talk to each other they have to be within the same subnet. So they have to have IPs from the same, from the same subnet, and they have to have the same they have to be part of the same layer 2 broadcast domain. So that is intent information. Right? That's the desired end goal. And this is also important for diagnosis, because when something happens, let's say an event gets executed, gets triggered from here. Let's say a BGP session is down on the switch, right? And if that's down, then you won't be able to route traffic from this switch. So if you're using symmetric RB or some sort of routing, then you won't be able to get out of that switch. Or I don't know. There's some additional impacts. So let's say that BGP session with the spines is down, or some external system is down, right? You get an event, and in traditional systems, that event is interpreted, and there's a root cause analysis process that happens. And the issue with root cause analysis is that it works in general if you have a correct topology information, and potentially intent is less common. But accurate topology information, and having accurate topology information for tools that are not part of the provisioning process or automatic discovery process is very difficult and error prone. Hence, even though the algorithms are extremely sophisticated, they sometimes, or often fail to provide the proper value because of this lack of information. So, but in our system, especially if you're building this topology and the intent information from the start, but potentially using MetalSoft, you can, in effect, have the AI do a proper diagnosis, because we receive the event. Right? This is the event. The event goes into the AI. The AI analyzes the event and say, oh, okay, there's a BGP session that's down. The switch name is this. I'm gonna look up in the topology information where is that switch connected to, what its neighbors, what's the intent related to the respective BGP session. Should it be up, even, and if so, where? And so it can actually, do initial troubleshooting, and a proper diagnosis can identify what the problem is. Diagnosis is key to the next stage, right? You cannot do remediation unless you have proper diagnosis, and you cannot do proper diagnosis unless you have proper data. And as well as, again, access to the tools, because diagnosis may mean, oh, my BGP session in the logs, it says it's a problem with the BGP, but I want to see if that's the case right now. I want to see if it's, moving up and down. I want to check the logs. And so the AI needs to use the deterministic tools, get the logs, get the BGP status, get the LLDP neighbors, get the logs, see if there's a transient problem, what the problem is. Is it with the transceiver? Is it with the cabling? Is it something that, is just down and needs to be replaced, or, what the problem is? And so all these three aspects, the topology information, intent information, deterministic, and safe access to the equipment, are required to the proper diagnosis, and then eventually remediation. Now, remediation is part of that concept of autonomous infrastructure operations. Autonomous would mean the system will need to self-heal itself. So assuming the diagnoses are correct, remediations will also have to and can happen automatically. This, in fact, is more deterministic than, doesn't necessarily need to be AI driven, because sometimes it just means AI has decided to reprovision the BGP session or reinitialize the BGP session, maybe change the AS number, for example, right? Or so it's the act of provisioning a BGP session is deterministic, but the decision is typically not, right? That's where the AI can really bring value into this whole process, right? So, but then once the BGP session and with a different AS number has been changed, that information needs to be fed back into the intent, right? So that the AI knows what's required, or the state of the desired setup. And so all of this entire process needs to happen in a system. Now, MetalSoft provides this. Right? MetalSoft provides end-to-end tool deterministic tooling, provides AI agents to do operation and diagnosis. It does not do remediation right now. It could, but for now we're in the stage of we want to see if the diagnosis is correct or not. But the end goal is to do automatic remediation as well. And on the operation side, MetalSoft provides a mechanism to do things like to talk to the chat and say something. I want a Kubernetes cluster. What's the the best server type for this operation, for this workload? And it's gonna and then please create it for me, and it will create it for you. It will create the respective infrastructure. So, or you can you can operate at the admin level as well, right? So operation diagnosis is happening. But taking a step back and talking about other solutions, if you want to implement this with something else, the very first thing that we recommend you to do is to start with the data. You have to have clean data, and the data can only be achieved, at least from my perspective, if you eliminate a human from inputting the data. Right? You need to be able to automatically discover the connections, automatically discover and update all of the required information. As long as you have the engine and the capability to do that, then you are definitely much closer, than many of the organizations out there, frankly, with regards to the AI adoption race. Thank you for watching.